Good morning, students. Myself, Vijay Shankar from EC Department, Civil Engineering College. Today, we are going to discuss about a few more examples in the transformation that is related to the convolution functions. Another example: x of n is equal to 1 by 2 whole power nv of n. Convolution. This is a convolution, my dear student. Don't think it is a plus. Convolution of 1 by 4 whole power n v of n. Convolution of time domain means what is the frequency domain? Multiplication. The 1 by 2 whole power n v of n is a z by z minus 1 by 2 multiplied with 1 by 4 whole power n v of n is a the transformation is z by z minus 1 by 4. It is a positive power, my dear students. In the negative power, 1 by 1 minus 1 by 2 z inverse. Remember this. That z inverse only 1 by z will get z, and this z will get in the numerator. Okay. Positive powers of z is z by z minus a and z by z minus a. What is a here? 1 by 2, and here also a is 1 by 4. Multiply these two. According to the convolution property, time domain is convolution, the frequency z domain is product. Simplify it. And ROC is, what is ROC? Is in between. Z is greater than 1 by 2 and Z is greater than 1 by 4. Okay. Both are greater than only. This is suppose inside here and here it is a greater than 1 by 4. So 1 by 4 and this range is 1 by 2. Greater than, here it is a greater than only. Greater than 1 by 4 and greater than 1 by 2. Greater than 1 by 2. So which is where it is overlapping occurs here? 1 by 4 it is a greater than, there is no any overlapping here. And greater than the 1 by 2 there is a overlapping occurs. So take only the Z is greater than 1 by 2. ROC is Z is greater than 1 by 2. Got it, my students? Now, another example in the convolution only. Another example in the convolution. X1 of n is 2, 1, 0, minus 1, 3 is the sequence is given. X2 is 1, minus 3, 2 is given. So there is no any arrow mark here. No arrow mark means the first value is n is equal to 0. The transformation of a convolution is a product of a z domain function. So x1 of z having the 4 values from 0 to 0, 1, 2, 3 and 4. 0 to 4 x of n z power minus n. So expand this value as n is equal to 0, the value is a 2. N is equal to 1, the value is 1. So z power minus 1. N is equal to 3, there is a 0 value is a 0. N is equal to 4, minus 1, z power minus 3. And n is equal to 4, 3 z power minus 4. Okay, after that is the x1 of z, we got the equation. And similarly, x2 of z, what is the range of x2 of z? 0, 1, 2. So 0 to 2. 0 to 2. X of n z power minus n. So x2 of z is equal to, expand this value. When n is equal to 0, the value is a 1, z power 0 is a 1, minus 3, n is equal to 1, z power minus 1, n is equal to 2, the value is 2, z power minus 2. So x2 of z we got. According to the convolution, the time domain functions is a product, not the product. Time domain function is a convolution. Z domain function is product. So we multiply the x1 of z and the x2 of z. So in the next way, multiply these two. 2 plus z inverse minus z power minus 3 plus 3 z power minus 4 multiply with 1 minus 3z inverse plus 2z power minus 2. Multiply and 2, after getting this, write it order of the sequence, z power minus 1, minus 2, minus 3, there is no 4, 5 and the 6. So write the coefficients as a sequence. x1 of n with the convolution of x2 of n, the sequence is a 2, minus 5, 2, or the 2 is a 1, and z power minus 3, the coefficient is 1, z power minus 4 is a 6, z power minus 5 is a minus 11, z power minus 6 is a 6. Got it, my dear students? Okay, the given function is a sequence. You can write the convolution is also in the sequence. Only have to remember here the convolution in time domain means you can write the product in the z domain. Got it? Find the x of infinite of the below. What is the x of infinite means? X of infinite is nothing but the final value theorem. Nothing but it is a final value. Nothing but is a final value theorem. Final value theorem. So what is a final value theorem? Limit n tends to infinite, x of n is equal to x of infinite, that is equal to limit z tends to 1, z minus 1 into x of z. Okay. For the first example here, limit z tends to 1, z minus 1 into x of z. What is x of z is given z plus 1 by z minus 0.6 whole square. Substitute the z is a 1, 1 minus 1 is becomes a 0. The first example. For the second example, the limit z tends to 1, z minus 1, z minus 1, z minus 1 x of z. What is x of z is given? The 2z plus 3 by z plus 1 and z plus 3 and z minus 1. So we have the z minus 1 and z minus 1. Substitute z is equal to 1. 2 plus 3 is a 5 and z, substitute the z is equal to 1. 2 into 4. That is a 5 by 8. 5 by 8, my dear students. So in the final value theorem, you can find out x of infinite for the given function of z domain x of z is equal. Okay. Similarly, the next example, see here, find the x of 0 of the below. What is the x of 0? Nothing but initial value. Initial value. What is the initial value? Says saying that limit n tends to 0, x of n is equal to x of 0. That is equal to limit z tends to infinite x of z into z. Z into x of z. For the first example, if I am taking here, limit z tends to infinite, z into, what is the x of z here? Z plus 1 whole divided by z minus 0.6 whole square. 0.6 whole square. That is equal to limit z tends to infinite, z, you take the z as a common here, 1 plus 1 by z, and here also you can take the z square as a common because it's a whole square, z square, 1 minus 0.6 by z So here the z into z, z square is get cancelled. Now you can substitute limit z tends to infinite. 1 plus 1 by infinite by 1 minus 1.6 infinite. This value is infinite. 1 by infinite is nothing but the 0. 1 plus 0 by 1 minus 0 becomes of 1. The value is 1 for the x of z is equal to z plus 1 by z minus 0.6 whole square. See, the value is 1. The similar fashion, you can substitute z tends to infinite, z into 2z plus 3, z plus 1, z plus 3, z minus 1. Take the z as a common in the numerator, 2 plus 3 by z. And here also take the z is a common in all the three terms. That becomes of z cube, 1 plus 1 by z, 1 plus 3 by z, and 1 minus 1 by z. Okay. And z get cancelled, and here the z square is there, z cube is there. So z. Now we can substitute the z tends to infinite, and numerator having the z is there. Not the numerator, denominator having the z is there. Because the numerator z square and denominator is a z cube. Z square get cancelled. You get the 1 by z into the total function. 1 by z, 1 by infinite becomes a 0. The total function becomes a 0. The first example, initial value is a 1. For the second example, the initial value is a 0. Got it, my dear students? Now you go for the another examples. Okay, it's complete of the Z transformation. Examples of Z transformation. Next is the inverse Z transformation. I will give the brief explanation how we can find the inverse Z transformation examples. And tomorrow class you can do the with equations. So what is the Z inverse Z transformation? X of n having the Z transformation is x of z, and x of z inverse Z transformation is x of n. What is the formulas for here? This is a definition of a Z transformation. Z transform. X of z is the sum of n is equal to minus infinite x of n z power minus n. And inverse Z transformation formula. We use this formula to derive Parseval's theorem, and another one is there. So one of the two properties we derive by using 1 by 2 pi j, the multiplication also. Multiplication property and Parseval's theorem, we derive this by using this inverse Z transformation formula. Inverse Z transformation formula, and this one is a Z transformation formula or the definition. 1 by 2 pi j, the integral x of z, z power n minus 1 dz, inverse Z transform formula. So let the x of z is b naught z power n, b1 z power n minus 1. So decreasing this power, and b1, b2, b3, and so on the bm, capital M minus students. And similarly, the denominator is the z power n, capital N, plus a1 z power n minus 1, a2 z power n minus 2, and so on. The maximum it is a suffix n, capital N, where b0, b1, b2 are the numerator coefficients. A1, A2, A3, and AN is a denominator coefficients, and here is a Z power n. There is no any A0. Remember that, my students. The roots of the numerator are called as zeros. The roots of denominator are called as poles. Zeros is represented in the plane is like this 0, and poles we can represent it as a cross mark. Got it? Basically, there are four methods to find our inverse transformation by using the power series or long division method, power series or long division method to do the inverse transformation or to solve or to evaluate. Basically, there are 4 methods to evaluate or you can solve the inverse transformation by using the power series or the long division method, a partial fraction expansion method, and a residue method, and finally by using the convolution integral method also. By using the convolution method simply. Okay, because it is a Z transformation, you can use the convolution in the discrete also. Not it is an integral method. Integral we are using for the continuous. Okay, there is 4 methods we are using to find out the inverse transformation for the given function x of z. The 4 methods are power series method or long division method, partial fraction expansion method, second method, and third method is a residue method, and fourth one is a convolution integral method. The first one is long division method. Long division method is a simple and does not give a at least form of expression for the time slot x of n. Further, it can be used only if the ROC of given x of z is either in the form of z is greater than or the z is less than. That is, this method is useful when the signal is either right-sided or left-sided. The long division method, or it is a power series method. Power series method is nothing but the sum of minus infinite to infinite. You can do it as a right-sided from 0 to infinite or left-sided from minus infinite to minus 1. The partial fraction method enables us to determine x of n, making use of our knowledge of some basics of Z transform pairs and Z transform theorems. By using the partial fraction method, directly the expression, what we get, the expression 1 by 1 minus U Z inverse. That is one of the Z transform pair or the Z transform theorems according to the a power n x of mu of n. Okay, you can write as direct equation in terms of time domain function. And coming to the third method, the integral method or residue method requires a knowledge of the theory of the complex variables, but it is powerful and it is also the useful. A residue method, you can find out the series there and apply again the partial fraction method, and you can find out the time domain function. And the last one is a convolution method. The convolution integral method uses convolution property of a Z transform and can be used when given x of z can be written as a product of the two functions. For the given two functions, whether or not given the two functions, for the given function x of z, you can write as x1 of z and the x2 of z, and that product individually can find out the convolution and substitute in the convolution integral and find out the final equation in terms of the time domain. So these are the four methods we have used to find out the inverse Z transformation for the given x of z equation. The first method you can take is a long division of the power series method. This method can be preferred when and only when x of n right-sided or it is a left-sided. Z is greater than is a right-sided, Z is less than is a left-sided. Case 1, if I am taking the right-sided, Z is greater than the infinite. So definitely in the function not is a greater than, my dear students, it is alpha, it is greater than the alpha something expression, the x a is, if it is greater than the infinite, nothing is there. Simply it is a variable of alpha, or it is a greater than the a. Alright. Now if I am taking from the right side, it means 0 to infinite x of n z power minus n. Expand this function, a long division method, or the power series x have 0 z power 0, x of 1 z power minus 1, and so on. X of infinite z power minus infinite. If z power minus n, multiplicand is x of n, the series is x of n is equal to x of 0, x of 1, x of 2, x of 3, and x of so and so on. And the case 2, the left-sided z is less than the alpha here. The x of z is equal to sum of minus infinity to 0, x of n z power minus n. Actually, it is a minus 1 because it is a discrete. Already we taken this right side, it means from 0, left side, it means it is a minus 1. Okay, whatever it is here, we are explaining about that. The series, what we have to take the coefficients of the z power minus 1 and z power minus 2 and so on. In this, the z power is a positive power. So on, x of minus 3 z power 3 plus x of minus 2 z power 2, x of minus 1 z power 1, and x of 0 z power 0. Here, z power plus n is a multiplicand is for the x of minus n. So the sequence is x of n is x of 3, x of minus 3, x of minus 2, x of minus 1, and x of 0, so on. Okay, this sequence will get positive values of the signal x of 0 to x of infinite. For the left-sided sequence, x of n is the negative values of n values, x of minus 3, minus 2, minus 1, and the 0. Right-sided means it is nothing but the causal signal. For causal, right-sided signals represents the numerators, denominator, numerator and the denominator ascending order of z power minus 1. Ascending order of the z power minus 1. For non-causal, left-sided signals represents the numerator and denominator in descending order of z power minus 1. Numerator and the denominator in descending order of the z power minus 1 and ascending order of the z power minus 1 to get the causal and the non-causal signals. Okay. And right-sided, z is greater than the some variable is alpha, ascending order of z power minus 1. The left-sided is z less than the alpha, descending order of z power minus 1. Let's take one example here. Find the inverse z transformation of the x of z function, the signal x of z, z power 3, 2 into z power 2, z power 1 plus 1 minus 2 into z power minus 1 minus 3 z power minus 2 plus 4 z power minus 3. It's a combination of positive powers of z and the negative powers of z we have. So x of z, according to the definition of the z transformation, x of z is equal to sum of n is equal to minus infinite to infinite x of n z power minus n. So expand from the minus infinite, x of minus 4 to positive powers of z, z power 4, x of minus 3 z cube, x of minus 2 z square, x of minus 1 z, and x of 0 z power 0 plus, and now from here inwards, there's a positive powers of z, negative powers of z, sorry, x of 1 z power minus 1, x of 2 z power minus 2, x of 3 z power minus 3, x of 4 z power minus 4, and so on the infinite. See, z power 4, 3, 2, the positive powers is multiplicand the minus 4, minus 3, minus 2, and z power minus 2, minus 1, and the 0 is x of 2, x of 1, and the x of 0. Okay. Now, these are the series of left-sided, not the left-sided, it is a right-sided because it is a positive powers. Positive powers is the left-sided. and negative powers of z is a right sided. Got it, my students? And now the given function is z cube plus 2z square plus z plus 1 minus 2z power minus 1 minus 3z power minus 2 and 4z power minus 3. So x of 3, x of minus 3, x of minus 3 is here. The positive powers of z cube value. Here you see the z cube is multiplicand for the x of minus 3. So x of minus 3 from this function, the value is 1. And x of minus 2 is a multiplication factor of the z square. So z square coefficient is a 2 here. So x of minus 2 is a 2. And x of minus 1, x of minus 1. Next here the x of minus 1, that is a z power 1 coefficient is a 1, is also z power 1. And here there is a 1 coefficient is a z power 0. Z power 0, that is x of 0 value is a 1. And z power minus 1 coefficient is a x of 1. So x of 1 value is a 2. And z power minus 2 is a minus 2, my students. Z power minus 2 coefficient is a x of 2. That is x of 2 is equal to 3. And z power minus 3 coefficient is x of 3, that is a 4. So we got the sequences is 1, 2, 1, and the 0 value you can represent it in that sequence as arrow mark. So 1, 2, 1, the sequence is 1, minus 2, minus 3, and the 4. Okay. In this way, you can find out the Z transformation by using the power series or the having negative powers of Z and the positive powers of Z. Take the coefficient, you can substitute in the sequence of x of n and give the arrow mark when n is equal to 0. Got it, my students? And the transformation of delta of n is equal to 1. The transformation of delta of n plus n naught means it's a shifting function. So for the shifting function, you can write as z power n naught, whatever the number of samples is shifted. N plus means that will get the positive powers of z because it is shifted towards the left side. N minus n naught means it is shifted towards the right side with the negative powers of z, z power minus n naught. And you have to write down that by using this sequence given the z transformation, and you have to write that in the time domain function. So inverse z transformation of x of z is equal to is already the sequence we got. Now in the another method way to find this sequence in terms of the delta functions, z inverse of the total powers we have, z cube, 2z square, z plus 1 minus the given function. Inverse z transformation of z cube here. Z cube means is a positive powers of z. So with the shifting of how many number of samples here? The 3 samples. So delta of n plus 3. And z square, it is also shifting towards the left side with the 2 samples. So the coefficient is a 2, delta of n plus 2. And here the z is there, z power 1 means how many number of samples if shifted to the left side? 1 sample. So you can write as a delta of n plus 1 and coefficient is 1. And minus 2 into z power minus 1. Z power, here the 1 is there. For 1, delta of 1 only. There's a transformation of delta of 1. Delta of n is a 1. 1 inverse the transformation is a delta of n. And negative powers of z is shifting towards the right side with 1 sample is shifted. Delay function 2 into delta of n minus 1. And here the 2 samples minus 3 into delta of n minus 2. And here there is a 4 into delta of n minus 3 and so on. The way to the 2 methods we have, we got the sequence and directly by knowing the standard equation of the z transformation delta of n plus n naught, delta of n minus n naught, apply the inverse z transformation, you can write as in terms of delta impulse function. Got it, my dear students? 2 two methods we did, as in the sequence method, and both are in the same. By taking off positive powers and the negative powers, you can write the time domain function. And again, the sequence is the same: 1, 2, 1, 1, -2, -3, and the 4. Then you go for the division method. The saying is a division method, long division method also. X of z is equal to 1 by z minus a is given, and its ROC is z is greater than a. Z is greater than a, so it is a right-sided. So represented the numerator and denominator in the ascending powers of z power minus 1. Okay, we already discussed the right-sided means ascending order of z power minus 1. Left-sided means descending order of z power minus 1. Only you have to remember that one. So the given ROC is greater than a, the power series method, or it is a long division method. Because it is a right-sided, remember that it is ascending power of z power minus 1. Okay, x of z is given 1 by z minus c is a positive powers. Take the z as a common, 1 by z into 1 minus a z inverse, and take this in the numerator, z inverse by 1 minus a z inverse. Okay, 1 minus a z inverse, ascending order. Ascending order means -1, -2, -3, and so on, the values we can take here. Okay, so I'm taking here the 1 minus a z inverse with the divide with the z inverse. 1 into, how many times you can divide this? Z inverse multiplied with 1. So z inverse minus a into z power minus 2. Take the minus and the plus, both are get cancelled. A z power minus 2. For 1, you can multiply again a z power minus 2. Multiply with this function with the a z power minus 2, and so on, getting the last function. So what is the coefficient here? Coefficient is z power minus 1, a into z power minus 2, a square z power minus 3, a cube z power minus 4, and so on. Got it, my students? Even here it is also the z transformation only, in terms of z values only. So 1 by z minus a, you can write this as in terms of z power minus 1, a into z power minus 2, a square into z power minus 3, a cube into z power minus 4, and so on. And this function you can read it as a sum of because here the value is minus 1. Minus 1 means z power minus n is there. So start the n is equal to 1 to infinite, because this is so on we'll get the division method. 1 to infinite. The z value, see here the z power minus 1, minus 2, minus 3, minus 4, and so on. Goes on, it is a minus 1, minus 2. It's a decreasing value. And the what is the a you can observe here? A value is increasing in the ascending order. See a power 0, a power 1, a power 2, a power 3, and so on. So I started here, it is a n is equal to 1 means a power 1 minus 1. Then only you'll get the a. 1 minus 1 is a 0. A power 0 value is a 1. Is a coefficient for the z power minus n. Nothing but z power minus 1. Okay. So a power n minus 1, z power minus 1 is the sum of the equation for the coefficient what we got here. Sum of n is equal to 1 to infinite, a power n minus 1, z power minus n. Got it, my students? Now I change this as minus infinite to infinite, minus infinite to infinite, because it starts the 1 to infinite. 0 to infinite means it is multiplied with the mu of n. But it starts from the mu of n is equal to 1 means one sample is shifted towards the right side. So what is the mu of step function? Mu of n minus 1 is multiplied for the a power n minus See, actually, sum of n is equal to 0 to infinite means unit step function is there, multiplying. But it started from n is equal to 1 to infinite, means the step function is a mu of n minus 1. One sample is shifted towards the right side. One sample. Okay. So mu of n is started from the 0 to infinite as the magnitude is 1. And the mu of n minus 1, see I wrote, is a continuous function actually, the diagram 1. So it looks like it's shifting one sample towards the right side. Okay. So change the limitations of n is equal to minus infinite to infinite, a power n minus 1. Write it as a mu of n minus 1 into z power minus n. Got it, minus function. See, what is the x of n now? Is the total function as a x of n, as in the z transformation x of z is equal to. So x of n is equal to a power n minus 1 mu of n minus 1. Mu of n minus 1. What is the sequence now? We got when n is equal to 0, when n is equal to 0, a power minus 1. And n is equal to 1, a power 0, that is a 1. And a square, 2 minus 1 is a, 3 minus 1 is a square, and so on. Got it, my dear students? This is a sequence we'll get for the x of n, and the x of z is given 1 by z minus e. By using the long division method, or it is a right-sided, you have to remember that is ascending order of the powers of the z. Ascending order of the powers of the z power minus 1. Z power minus 1, minus 2, minus 3, minus 4, and so on. Okay. Similarly, if it is ROC is a less than a, the same function if I am taking, but with ROC is a less than a, what do you have to do? Here, first of all, you can remember that the z is less than a, the left-sided, so the representing of the numerator and denominator in descending powers of z power minus 1. Descending powers of z power minus 1. So again, simplify this 1 by z minus a as z inverse by 1 minus a z inverse. Numerator is z inverse, and denominator you can write this as a descending order. Descending order means previously we start from 1 minus a z inverse. Now we can divide the z power minus 1 with minus a z inverse plus 1. Minus a z inverse plus 1. Got it, my dear students? Because it is a descending power of a z power minus 1. So now I am taking the minus a z inverse plus 1. Only the difference here. 1 minus a z inverse plus 1 means now it is descending orders. See here the z power minus 1. Now multiply with how much value to get it is a minus z inverse means 1 by a. A get cancelled and it is a minus, and because it is a plus value, you can keep the minus e. Minus 1 by a is multiplied with its function of minus a z inverse, we'll get the z inverse. 1 with minus 1 by a, so on you can do. You'll get minus 1 by a, minus 1 by a square z power 1, minus 1 by a cube z cube, and so on. Now you can see, observe, you will get is a z powers is a positive powers. Positive powers. Because it is a left-sided, definitely the powers of z is a positive only. So x of z is equal to minus 1 by a, here the z power 0, z power 1, z square, and so on. Z power 0, 0 is there, so we can keep that as a sum of n is equal to 0 to infinite as a z power n. Observe the a value, how it is changes, minus 1 by a square, a cube, and so on. So we started from n is equal to 0 here. here to get the a value, and it is increases also. Keep the function as a power n plus 1. Substitute a is equal to 0, a power 1, a is equal to 1, a square, and so on. So the given function is minus 1 by a power n plus 1 z power n. Okay, z power n. So actually, in the Z transformation definition, it becomes of z power minus n. Minus n. So change is z power minus n. Power is changes means the limitations changes to the negative values. Or either negative values of summation, limitations you can change. In the powers, you can change the positive to negative, negative to the power. So I'm keeping the z power minus n here. And also a power minus n, the powers, whatever the powers we have, changing the positive powers to the negative powers, and change the limitations as 0 to minus infinite. 0 to minus infinite. What it matters, students? Because it is a left-sided sequences. And that is equal to sum of n is equal to minus infinite to 0 minus 1 by a power minus n plus 1 z power minus n. And this sequence you can observe minus infinite to 0. If it is a minus infinite to minus 1, the step function is mu of minus n minus 1. But here minus infinite to 0 because it is a folded function. Keep that summation is from minus infinite to infinite. Mu of minus n is multiplied for the x signal minus 1 by a power minus n plus 1. So this is x of n. We got the definition of the Z transformation. N is equal to minus infinite to infinite, minus 1 by a power minus n plus 1, mu of minus n z power minus n. So only the representation the mu of minus 1 is a left-sided sequence. Mu of n is a right-sided sequence. From this function, x of z is equal to, what is the signal x of n? Minus 1 by a power minus n plus 1 mu of minus n. Okay. When the given ROC is left-sided means keep the descending order of the powers, descending order of the power of z power minus 1 and ascending order of the powers of minus 1.